Okay, so the thing is that thing is that one there's a so I'm going to discuss more about do not leave the users out of the model, and what it mean is that what it's trying to say is that like there are lots of users and there's a lot of user data, uh, and because of the advent of new technologies, we are able to capture lots of user data. For example, we are able to capture clicks on a website, the user sessions, how long the user stays in the website from start time to finish time. That is called user session. And and churn, we are able to capture churn. What does it mean? Well, churn is basically the rate at which the user is leaving leaving the site and at a particular period of time. All these information are really useful and valuable, but they don't capture everything. They don't capture, but we capture lots of data, but we don't capture everything. That's what I was trying to say. And also and also we and also when we do this analysis using this lots of user data, we face a problem most of the time is about hidden variable problem. So what do you mean by hidden variable problem? Hidden variable problem, it means that when we do the analysis using this user data, we forget the user. We forget the user. We are just looking at. It's really easy to miss out on the user because we are dealing with a web product and we don't see the human there. Let's say if you go to let's say we are in some store, and when we sell a product, we see the human right in front of us, right? But when we are analyzing this user data, we see them as just as data, but forget that there's a human who is generating those data, and that's a hidden variable problem. And since we don't capture all the user data, it's really easy to it's easy to fall into this hidden variable problem trap. So that's what it means. Let's say, just give an example, right? Let's give an example. Let's say there are there's a product, and there's a product, and the users are coming from the two sites. Let's say 50 users are coming from Google and 50 users are coming from Yahoo, right? And what we see is that like what we see is that people who are coming from Google are buying in more rate than people who are coming from Yahoo. And okay, so that's good. So the what so is now is solution to give more ad in Google than Yahoo, or it's a, let's say business decide to improve the sales. Business decide to give more ad in Google so that the revenue is increased. Then what would happen? Would the sale would increase? Probably not, because we are just dealing with some data. Okay, I have this product, and people are buying from the Google are more than people who are buying from the Yahoo. But if you just increase the ad without understanding who the users are actually buying those products, then we would never understand. We would never be able to target the particular user who are actually responsible for buying from the Google. So we have to understand who the are actually users. And also, early. What this chapter talks about is that descriptive analytics is different than predictive analytics. What it means is that, like, okay, so we have a lot of data, right? We have lots of data, and when you have a lot of data, that's a big data. So when you have a big data, then one of the inclination of the company is to do the big data analysis, using a predictive analysis, predictive analytics. So predictive analytics is a very powerful tool. That's for sure. It is a artificial intelligence, machine learning. What it does is that it predicts whether a user would buy a certain product or no, right? That is what that it does. It just predicts in the future. It goes to the future and see whether this user will buy certain product or not. predict the human behavior, and it depends on lots of data. We need lots of data to do that, right? But what we are trying to do here in using this our problem is not predicting, but our problem is to understanding what caused the people to buy, right? What causation is different than prediction. Let's say we are looking at the past and see, okay, we have the large increase in sale because of what? We are trying to find the causation of what caused the increase in sale and what caused the decrease in sale. So those are the causation is different than going looking at the future and trying to predict what is something will happen or something may not happen. So those are two different. We are looking at the past, and the predict descriptive analytics look at the past, and a predictive analytics look at the future. So there are two different problems. We have to understand that, and the causal inferences does not benefit by having huge number of data. It is basically experimenting using a two situation where you have this A/B test. It is called A/B testing, where you have a small number of people, a selected number of people are randomly selected, are given a certain scenario which you want to test, and other people are not given that scenario which you want to test, and that's called causal. That's A/B testing, and that's the causal inference. What causal inference is trying to understand the impact of certain variable to a variable of interest. So that's called descriptive statistics.